Okay, now the question that we are reading is, what do you notice about the distance being covered as each second passes? Now see here, we can see in 1 second it has covered this much distance. In 2 seconds it has covered this much distance. In 3 seconds, 4 seconds it has covered this much distance. It means here, this graph is a curve, correct? So as the each second passes, the amount of distance covered is increasing. It means it's an accelerated motion. So here the answer that you are going to write is, as each second passes, okay, that we don't have to write, the distance covered is increasing. All right. How may you answer to question 1 affect your understanding of what is happening to the velocity as each second is passing? As I said, it is an accelerated motion, so the velocity is increasing. Question number 35. What is the displacement of RC car between 0 to 2 seconds? Okay, I will just zoom in this graph. 0 to 2 seconds. Just look at this. 2 seconds is here. This is 2 seconds. And then this is going to be the distance traveled. Now see, 0 to 10 is divided into 5 parts. 1, 2, 3, 4, 5. It means each part is 2 meters. I will have to check with the units. So this part is going to be 4. Let me check with what the unit is given. Okay, it is meters only. So in this part of the graph, you can see for 2 seconds, it is like this. So this part of the graph is going to be 4 meters. Any questions? Okay. Oh. That was 35. What is the average velocity of the car during 0 to 2 seconds? Now see how much distance it has covered. It has covered the distance of 4 meters in 2 seconds. So 4 divided by 2. That will be 2 meters per second. I am going to write down all of these afterwards. Total total distance upon total time. Total distance is 4 meters. Total time is 2 seconds. So 4 upon 2. I'm going to write all this. You will afterwards take it down. What is the Okay. Okay. What is the displacement of RC car between 2 seconds to 5 seconds? So I will simply take this difference between 2 seconds and 5 seconds. For 2 seconds, this is the displacement. And for 5 seconds, this is the displacement. Okay. So this part is 4 meters. And this part is 20, 22, 24, 25, 25. So 25 minus 4. This is going to be this difference from year to year will be the displacement between 2 to 5 seconds. So 25 minus 4, your answer will be 21 meters. Okay. The next part. What is the average velocity of the car during 2 to 5 seconds? 2 to 5 seconds. Okay. I've just written over here. The displacement is 21 meters. So this will be 21 meters divided by 2 to 5 is 3 seconds. So this is going to be 7 meters per second. is the answer to 38 question. How do your answer to question 35, 36 reinforce your notions in question 33 and 34? Answers to question 35 and 36. In question 33 and 34. Distance covered is increasing. You may answer to question 1 affecting what is happening to the velocity. Velocity is increasing. 35 and 36. What is the displacement? Okay, the amount of displacement is increasing, therefore the velocity is also increasing. This is what we mean to say. I'm writing this answer. As the displacement is increasing, the velocity is also increasing. Just copy that down. We'll go on to the next question. What is the average velocity for the entire time interval between 0 to 7 seconds? So you take total displacement divided by 7. Total displacement is 50 meters, as you can see from the graph. Total time is 7, so 50 divided by 7. You simply have to divide this. Seven 7.14 we will take up till 2 decimal places. So average velocity in entire journey is 7.14 seconds. How does the calculation in problem 40 compare with previous calculation of velocity? Previous comparison of previous calculations of average. See, here all the velocities which are there, how much is the velocity? The velocity keeps on increasing. Correct? In the last 1 second, how much is the velocity? 6 seconds to 7 seconds, just find that. Yeah. Between 6 seconds to 7 seconds, how much is the velocity? For 6 seconds, the displacement is here. And for 7 seconds, the displacement is here. This is 36. And this is 50. So in last 1 second, the velocity is 14 meters per second. Here the velocity is increasing. In the last 1 second, the velocity is 14 meters per second. So average velocity is 7 meters per second. Average velocity is less than that. See, here the velocity is how much in first 1 second? This is 2 meters per second. Correct? It is covering 2 meters. In another 1 second, it is 2 meters per second. After 3 seconds, it has covered 9 meters. So this is 3 meters per second. 9 meters is covered in 3 seconds. So 3 meters per second. So here the velocity keeps on increasing. But the average velocity is going to be total distance upon total time, which is 7 meters per second. In last 1 second, it is how much? It is 14 meters per second. So in the previous calculations, the velocity just keeps on increasing. And in last 1 second, it is 14 meters per second, which is more than average velocity. This is what we are supposed to write. Velocity keeps on increasing. Ah, it can keep on, it will keep on changing because it depends on traffic conditions. If there is traffic, then the velocity will decrease. If there is a highway, then the velocity will increase. Hmm. 10 hours. It will be average speed. For average speed, 10 hours will be accurate. But every time the speed will not be 100. Sometimes the speed will be 0 also, where it has stopped. And it can be 200 also, where it is running on the highway. Okay. Mm. Yes, total distance divided by total time, that will give you the average. Okay, this question is done. How can velocity be 10 meters per second? It is 10 meters in 4 seconds. Total distance upon total time will be 2.5 meters per second. Right? They have not asked displacement. They have not asked displacement. They have asked velocity. Hmm. Yeah, it is correct. This point you are supposed to choose. And from here, you are going to take this graph. After 10 seconds, you are going to take it on x-axis. This is minus 10 meters. In the class also, you will keep on calling. Hello. Yeah. If tomorrow I'm traveling, I don't think so I will be able to take any extra. Yeah, tell the answer for C part. The time after which he will reach the starting point. There will be two answers for this. One answer is this. He will reach to the starting point. This point is 1, 2, 3, 4, 5, 6, 7 seconds. E is the point. So after 7 seconds, he will be reaching the starting point. Another answer is also there. From starting, they have asked. From starting means you have to take it from 0. And this is where the displacement is 0. So count how many seconds are there. 1, 2, 3, 4, 5, 6, 7 seconds. After 7 seconds at point E, he is at the starting point. Another answer is also there. Second answer is also there. This is also he at this point also he is reaching at the starting point. So you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. After 7 seconds and 13 seconds, he is at the starting point. That will be the answer. Got this? Why from 10? They've asked from the starting point. Why do you start from 10? The time after which he will reach from the starting point, it means this is going to be after 7 seconds and after 13 seconds. These two will be the answers. Okay. Yes, yes. From beginning only we are supposed to count it. This is the next question that you are going to solve. You are going to write down what data is given to you. You're going to use the formula of acceleration. You'll substitute the values and get the answer. Acceleration is already given to you 3 meters per second square. This is acceleration. And this is initial velocity. Sorry, this is the car starts with velocity. Okay, this is your initial velocity. Time is given. This is time. We use the formula of acceleration. A is equal to v minus u upon t. These three things are given. A is given, u is given, t is given. You are supposed to calculate v. Change the subject of the formula and calculate v. If you change the subject of the formula, you are going to get v is equal to u plus at. You will substitute all the values and get the value of v. Velocity, how you are getting it in meters per second square? What is the unit of it? 29 meters per second, not only meters. Velocity unit will be meters per second. Yeah, this answer is correct. Okay. I'll see you in the next class. I'll upload this video and send you the link.